features that we want to put in Boron. And then an open question and answer sessions for anyone who are interested. So first thing I want to do is talk about what is USC trying to solve. And USC is really targeted for the enterprise market. So in the enterprise market, there are certain challenges that they are facing. So we're working with unsecure public networks. So the communication between the controller and the device sometimes may be traveling through the internet or some sort of public infrastructure. And some protocols lack solid two-way authentication as they communicate between the controller and the devices. The other problem is there are way too many protocol channels that are created, and you would have to do repetitious authentication whenever you do a handshake for any of those protocols. And there's no guarantee that that particular authentication method is as secure as you would like. The other thing another challenge is the need to support high volume and velocity. Because there isn't really any sort of southbound clustering support in many of these protocols that the enterprise uses. So our solution was to come up with something we call unified secure channel that would provide encrypted communication and mutual authentication that would have converged tunneling for all protocols. The architecture for USC is pretty simple. So we have a USC agent sitting on all the devices, and it communicates with a USC plugin on the OpenDaylight controller side. And between the plugin and the agent, we set up a channel between the two. And we also have a USC manager to help us manage some of the clustering, the RESTconf, the APIs, also monitoring the statistics, the metrics across the channels, and also some configuration aspects in the USC manager. So here's going over again. USC manager has security, clustering, config, monitoring. USC plugin has the protocol handler. The muxer demuxer we use to allow protocol multiplexing, which I'll be discussing momentarily. The USC plugin also has something called a call home listener. This is used for environments where you have your devices behind some sort of NAT or firewall, and you may need some sort of call home. On the USC agent side, we have the protocol proxy, the corresponding muxer demuxer, and the USC agent also acts as a call home client to initiate the connection with the controller side. Right. So what really powers USC is a header, which we defined. It's 8 bytes in size. And what we do is we take the protocol, we take the payload, and we have the USC header, which defines the USC version, the operation type, the application port, the session ID, and also the length of the payload. So if you take Netconf as an example, what we would do is if we have some sort of Netconf payload, we would actually extract it and put it in our own, run it through our USC tunnel with the USC header. There are some the way you would deploy USC is you would have your device and your controller. With or without the agent. Now, if you don't have an agent, then it would be non-secure. We call this the fallback deployment scenario, in the sense that we want to support legacy enterprise environments that do not have the USC agent installed in their device. So our USC plugin is smart enough to detect that and to fall back in that particular scenario. We also have a deployment scenario where you have the agent installed, but you don't want to run the security module inside the USC agent. In that instance, then there's really no authentication, no encryption that occurs, which means that you don't get the security benefits. But some groups may prefer having that for the benefit of having performance. Now, the common scenario for USC is to have an agent installed in the device with the security module enabled, and the channel will be using TLS for TCP communication and DTLS for UDP. Another scenario that we support is if your device is behind a NAT or a firewall. We call this the call home scenario, where the device initiates the connection to the controller using the call home, the call home client inside the agent of the device. So USC offers 4 major features, which I'm going to go into more detail. So it offers protocol multiplexing, mutual authentication, call home, and enhanced clusterings. And I'm going to go through each of them individually. For protocol multiplexing, what we mean is USC establishes a single channel between the device and the controller for TCP communication, and then another channel between the device and the controller for UDP communication. Now, through that single channel, we would multiplex the communication for different protocols. So you may have Netconf, SNMP, CAP, WAP, and in the future, when we support more of IoT protocols, then you would have all the IoT-related protocols like AMPQ or whatever. So the nice thing about having a unified channel with protocol multiplexing is that you can have a common security guarantee across that channel, because that channel we've already done asymmetric authentication with using certificates. And you would only have to do that single authentication handshake once and be able to guarantee that any traffic going between the device and the controller would be secure. The other feature that we provide is mutual authentication. And here, it's not enough to just have to authenticate the device. You also have to authenticate the controller, because you may have a rogue controller trying to act maliciously, trying to take over your devices. So we have certificates both on the device side and on the controller side. Now, an alternative to this that some other projects have done is to use a whitelist, a device whitelist. And we decided not to do that, and instead just to have certificates. I guess it's a different approach. So by authenticating both sides, we were able to ensure that rogue devices and rogue controllers do not maliciously damage our environment. The other feature that we provide is call home, and I mentioned this a little bit already. The idea here is that the device is sitting behind a NAT and a firewall, and if the controller tries to initiate a connection, it would find that the device is unreachable because it's behind a NAT or a firewall. So what you really need is for the device to initiate that connection through using the agent. This call home feature actually already appears in the Netconf RFC specification, but not all protocols have call home specified. So what we do is we provide call home for all protocols that use USC and use the USC channel. So connect to device via USC channel for protocols even with no call home support. The other feature that we support is enhanced southbound clustering. And as I mentioned earlier, this is not northbound clustering, this is southbound clustering. The scenario that you may have is a device is already connected through call home through controller 2. If you try to, let's say if you have an orchestration app that's trying to send some sort of configuration through controller 1, it would find that controller 1 cannot actually connect to your device because you have not established a call home connection to controller 1. With USC, however, we actually do southbound clustering such that when you send the configuration to controller 1, it will know to reroute that to controller 2 because controller 2 already has an existing channel to that device through the NAT or firewall. Right, so then this connection becomes successful and we can reuse the existing connection. Another scenario is the intercloud scenario where our enhanced southbound clustering can come into play. You may have environments where you have certain devices connected to, say, a private cloud that's being controlled by controller 1. You may have devices connected through a public cloud to another controller 2. And then you may have devices connected to a partner cloud through controller 3. And controller 1, 2, and 3 are connected through clustering. So in this scenario, you have one single orchestration app, and it doesn't really know if these devices are connected to private cloud, public cloud, or partner cloud. And you don't know if it's being managed by controller 1, controller 2, or controller 3. So in this instance, what USC can do is no matter where the message is sent by the orchestration app, USC will find is already connected to this controller, or if it needs to reroute to a remote. What it determines is, oh wait, I can't actually reach this device. So it sends it over to our USC clustering manager, which will go in and through a lookup, we have a table, a hash table where we kind of map the node and the controller that it's in. So we do a lookup and we've determined that it's actually in controller 2. So then we send a message to controllers to clustering manager, which sends it back to the controller 2's protocol handler and then sends that message along the way to the device itself. So that covers the 4 major features of USC: protocol multiplexing, mutual authentication, call home, and enhanced clustering. USC also offers a user interface that you can enable when you install ODL USC channel UI. And this is completely integrated with the ODL Deluxe UI, and it's loaded as a carafe feature. And it uses Deluxe modularity, which uses AngularJS as its UI framework. So the way it works is we define some services, some Angular services, Angular controllers, and Angular templates inside our USC UI module, which we then define in our blueprint. And then that gets bundled up inside the USC channel UI and gets loaded when you install the USC Channel UI feature. When you do install that, the USC UI appears as one of the items on the sidebar, and then through the UI, you can actually see metrics about your channels, such as the number of bytes that has gone in and the bytes that has gone out. There are some configurations required in order to actually use USC, and this is specified in our user guide. And I believe it's also specified in our developer guide. There are configurations that you would have to do to enable southbound clustering with our conf file. And then you can also specify the location of your certificates inside our USC properties file. If you are using our demo Netconf dispatcher, then you would have to make additional configurations to your Netconf XML to use the USC Netconf dispatcher XML instead. Right. So that covers the features of an overview of the features of USC. Now I want to go into what USC has done in the Beryllium release. So we followed a TikTok model of development. So in Lithium, we implemented a lot of the major features, the 4 features that we had discussed. In Beryllium, it was more of a bug fixing, performance enhancements, and also expanding our testing suites. So with Beryllium, we developed a USC agent Java, which is a Java-based test agent. And this is used for testing purposes. It's also used in our CSIT TCP system test suite, which is, you can go to Jenkins and see the reports for it. The reason why we keep saying that it's a test agent is because with our Java agent, we didn't care too much about the performance. We were more focused about being able to test the correctness of the USC channel features. So with USC agent, you can provide it with 3 flags: TCP flag, call home flag, call home IP. The TCP flag is true by default, being TCP, false if it's UDP. We also offer a call home flag and a call home IP for you to specify if the agent should initiate the connection to your controller. We also provided another test service called USC Agent Echo. So, going back to our deployment, you have the agent on the device, but the device may support multiple services like a Netconf service or SNMP service. In this case, we implemented something called an echo service, which doesn't really do anything other than echo the same bytes that it receives through what we call the echo protocol, which is just a funny way of saying, well, we're just going to return the same bytes in some sort of specified multiples. And the usage for it is you would specify your USC echo with the port of the service. So using the USC Agent Java and USC Agent Echo, we actually found some bugs that's documented in our Bugzilla. And we were able to do much more extensive testing in our lab and in ODL CSIT test infrastructure for both for functional testing, performance testing, and also edge case testing. In Boron, we hope to expand the number of demo dispatchers that we have. So right now we have the Netconf dispatcher, which works, but we'd like to expand that to cover more protocols like CLI dispatcher or an AMPQ dispatcher. We have also done some integrations in Beryllium with USC with the CapWeb project, but we like to see in Boron for us to collaborate with other projects as well to expand USC usage through other southbound protocols. We're thinking about collaborating with any other southbound plugins, whether or not they want to leverage some of the features that USC offers for free. So we have about 20 minutes left, I think. I kind of want to just open the floor to any sort of comments or questions that people may have about USC, or any suggestions on any features that they would like us to implement in Boron. So it's kind of open-ended for anyone with comments, questions.
So just a quick question. I was wondering if you had any non-Java agent implementations, or knew of any that are out there, particularly C or some low-level code.
So the agent, if you really want performance, you probably don't want to use the Java agent. You want to write it in C. And we actually do have one that we open sourced on GitHub. And it's inside our user documentation and our development documentation. I want to clarify that our C agent we have not tested. So you should use it more as to look through the code. Whereas our Java agent, we actually tested it. It's part of our Jenkins CSIT. So we actually heavily use it. The C agent use it with that caveat. So yeah.
I just wanted to add a little bit. The C agent is not really completely not tested. C agent we tested, but not as thorough or complete as Java agent. C agent, we also test most of those kind of features, and because of license reason, is not applying for Eclipse that license. So that's why we checked in separately, put in your link so you could download over there.
Yeah. Helen's correct. The other reason why we don't put the C agent inside OpenDaylight is that for anything in OpenDaylight, we would have to release under the Eclipse license, and unfortunately, the C one we had to release under the GNU one. So that's another caveat. All right. Are there any other questions or comments from people? For the Boron release, so the question was what we would cover in Boron. And in Boron, what we're going to do is try to cover more southbound plugins, like having a AMPQ dispatcher, and perhaps even a CLI dispatcher, so that we can get more. We're hoping to get more adoption in OpenDaylight by providing more dispatchers for various southbound protocols, so that they can use it, so that they can use USC.
Have you think about, like, as you mentioned, USC provided the southbound cluster, and that's very important as a controller. And OpenDaylight itself, for example, is also doing something related to that. Have you ever think about collaborating with them, maybe contribute the southbound clustering into the clustering project into OpenDaylight, or they even depend on this? Like instead of you have the OpenDaylight itself has two part of the southbound cluster.
Yes. So so the question was about whether or not we want to integrate with OpenDaylight's other southbound clustering. So for those of you who are not familiar, in Beryllium, the clustering team implemented something called Entity Ownership Service, which is also used for southbound clustering in OpenDaylight. Currently, OVSDB and OpenFlow uses entity ownership service, which is different from how USC implements its southbound clustering. So, but however, there is opportunity for us to collaborate. So definitely in Boron, one thing that we would like to do is reach out to the clustering team and work to see if we can contribute some of the work that we've done in USC to the entity ownership service. And also to reach out to other projects like OpenFlow, OVSDB, SNMP, and any other southbound plugins, whether or not they want to leverage some of the features that we already offer in our enhanced southbound clustering. But definitely, we should probably collaborate with the entity ownership service group to see if we can contribute some of our work, our existing work, into their code base. Yeah. All right. Any other questions or suggestions on features that you guys would like to see in Boron? Okay. Go ahead.
Can you explain how the bootstrapping works? How the certificate gets distributed to different clients? How you end up knowing if you have to call home or not? How is that managed?
So at the moment right now, the certificates, we don't have a mechanism to distribute and deploy certificates to the devices. We don't have that bootstrapping mechanism. Instead, the admin has to go in and actually install and configure the certificates directly into the devices. And that could be potentially a feature in Boron. That's a very good suggestion. That's something that we should consider doing in the Boron release, having a mechanism to manage the certificates or to even update the certificates across all the devices in the case that some set of certificates have been are no longer valid. Yeah, so that's definitely a feature. I think I will add that as part of our Boron planning for USC. Yeah, thank you for the suggestions.
When it comes to the clustering, you really mentioned kind of one open channel per device.
Mhm.
Are you supporting or plan to support redundancy or some kind of lag so you can have multiple channels open at the same time?
So we leave it to the device to decide if they want to have multiple channels to multiple controllers. But what our southbound clustering does is that in the case that there is only one single channel, then it reroutes to the right controller that is connected to that device. So in an instance where the admin wants to have multiple channels to multiple controller, he or she is open to creating multiple channels to their devices. So right now we don't have any sort of mechanism in our Java-based agent to kind of do any sort of load balancing if there are multiple channels. So that's something that we have not considered in our Java based test agent.
Could I ask why you think there should be a requirement between the controller with a particular device that you need to provide the multiple channels to?
Because the devices could actually be far away, being connected over multiple networks, and then you might want to have hot standby that is 2 links up, use only one, but if it goes down, then you're able,
So one option could be to have like an idle channel that is sitting there in case the active channel fails, then it would quickly switch over to the idle channel. That could be one option that we can consider for Boron.
Yeah, maybe on the device side, for example, it's very important device, like the AC, connected with the controller, remote controller, local AC, then they might need to have the idle one because it's very important.
Yeah.
For others, like if it fail, then you will create another one.
Yeah.
That's very good idea.
That's a good suggestion. I think that maybe we should expand the Java-based test agent to support establishing multiple channels to multiple different controllers. However, I think it still makes sense for us to maintain that between one device and one controller, we should have one single unified channel to that controller. Of course, the device can decide to connect to multiple controllers, and that's something that we can add in Boron.
One single active connection
Yes,
channel.
yes, one single active, or if we can have some sort of load balancing, then it could be configurable. I don't know if we'll be able to add load balancing, but if we do, then we can have multiple active channels, and you can configure this with some sort of flag and say, hey, I want X number of active channels. So that's something that we can definitely think about for Boron.
Are you providing some kind of API for the protocol to use or template? If you have, when you have new protocols, you have some kind of design guidelines on how they can integrate into USC.
Yes. So first of all, there's two aspects. Number one, we provide a RESTconf-based API for testing purposes, for visualization purposes, and it allows you to view the channel, add sessions, delete sessions. Then there is also a Netconf dispatcher, which kind of allows others developers to see how one would implement a southbound protocol on top of USC. So they would one would follow the example of our Netconf dispatcher inside the USC Git repository. And follow through with that. In Boron, we're hoping to expand on that and add more examples so that we can get the community to adopt USC more.
So right now we actually have one example on Netconf, which is HTTP based, and also we have one example for Kafka, which is UDP based. So if kind of protocol fits into one of those HTTP or UDP, could reference those examples on how you could redirect. Like before you Netconf, they could talk to the device directly. Right now they through the USC, and then USC provide all those kind of advantage for it. And like Kafka, they could also directly talk with the device, but they could also go to USC, and USC provide all those connection management, the certificate, and also other things. So those things certainly also could be used.
Yeah.
But that one part also could be documented
Yeah.
in a kind of way. So like these two.
Yeah.
Step-by-step.
So right now we're the only way we do it is we just say take a look at the Netconf dispatcher as an example and follow it. But I think that for Boron we need to put more of an effort in our documentation and say, hey, it's not enough to just look at it as an example. Here's the step 1, 2, 3, 4, 5 that you would need to do to actually have a southbound plugin, a southbound protocol use USC. So we should definitely focus on our documentation for Boron.
Which protocol particularly in your mind right now?
I was going to come to that. Last question. In your one of your first pictures, you were explicitly excluding OpenWeb in Netconf,
Yes.
right? But then later in the discussion, yeah, I think you had right after this one, yeah. See, you have the OpenPlugin explicitly excluded there. Was there any reason? Because we're working with open code.
security is because they are distributed. But we didn't find out much use cases like the open flow controller has to be set on a different security or far distance go through the internet. That kind of use case.
But we do have cases like this.
Okay, then if you that should be fine because anyway, OpenFlow in this one you could use HTTP, right? In a way. We need to test that. We didn't test it.
Yeah, we
The case where OpenFlow is used like this is when you have the switch remote, like in the case of a base station.
Oh,
The switch is remotely located, but the controller is in the central office or with the DSC or mobile gateway somewhere. Then you have some kind of embedded connection inside between the controller and the message going through. Could be public, could be semi-private connection. It's not like a simple link connection between the 2 points.
maybe if you don't mind, after this meeting, also you could follow up with them to give your use case to them a little bit more. So maybe we could test that also to Boron may do something.
yeah.
Which company you are?
No big deal.
Yeah, definitely. After the session, we should definitely talk. We definitely want to support as many southbound protocols as possible. OpenFlow was one that we have not investigated deeply or validate extensively. So it's one of those things that we really need the community to come and help provide us with some feedback on the use case and the testing for it.
Do you have any facility in the USC for a keep alive for idle circuits to validate that the connection is still operating normally?
So the USC, when a session goes down, it actually detects that the session, because it's constantly pinging it.
Okay.
So when the session goes down, it's marked as so in the UI, you would actually see it as being failed. That would be an indicator for it.
So in this high availability configuration that was being discussed earlier, if the idle connection died for some reason, some network equipment or some reason, you would detect that and try to reestablish it? Or?
So, well, first is detect that. Yes, we do detect that because the connection is, we do have like what you call a keep alive. So we kind of test if the connection is still there. Now we leave it up to the app, the orchestrator app or whatever, to respond accordingly when it fails. But if maybe that's something that we should discuss in Boron, maybe we can provide that as a flag. Hey, if it does fail and you want us to keep that alive, then we can continue. We can attempt to initiate another connection with that device. But of course, if it fails, usually there's a reason behind it, and some troubleshooting needs to be done to fix that. So we can attempt to make that connection X number of times and wait a certain period of time to do that. And so maybe it's worth adding some extra parameters to our USC properties file to do that. But right now, we detect it, but we don't respond to it. Is there a particular use case that actually would want the USC to keep that alive rather than leaving it off to the orchestrator app?
Well, I suppose it's from previous experience that when you're tunneling multiple connections through a system like this and the tunnel itself fails, then it can become a very complicated discussion amongst the various applications on how to reestablish connectivity and through what connection paths. And so I was wondering if you had some facility for that. It sounds like a flag may be sufficient, but just asking the question.
Yeah. All right.
If you have 5 protocols with a million connections,
Yeah.
and the connection goes down, who's responsible to reestablish it?
Yes. And
Any of those protocols or?
all of them need to know because they have their own issues to solve.
Yes, at the moment, like I said, we're able to detect it, but we don't respond to it. We were in the time of designing. I guess we were trying to leave that up to the orchestrator app to respond. But maybe adding a flag and having us respond to it would make more sense, or to at least give that option to any users of USC. All right, we have 4 minutes left. Are there any other questions from the audience on USC, or any other features that you would suggest for USC? Okay, then I'll return 4 minutes back to everyone. Thank you.